In this video, I'm going to do page 65 in Krugman's Macroeconomics, number 1. So 1a tells us that if the price of movies increases, fewer consumers go to see the movies. And the problem wants us to figure out what the variables are, determine whether which one is independent and which one's dependent, and then to show this graphically by choosing the panel that best represents the sentence. So first, let's consider that we have the two variables we have here, I would say properly, are, so we're doing 1a, the price of movies, whether it's expensive to go to the movies or not, and the number of consumers who go to see a movie. And it's typically going to be the fact that your variables are going to look like this: the number of something, the level of something, the price of something. Now, we are going to need to pick a panel that best represents the relationship between these two variables. So I need to figure out what the independent variable is, which is going to go on the x-axis here on the horizontal, the independent variable, and then the dependent variable on my horizontal axis. And so I need to ask myself, is it that the price of movies impacts the number of consumers who go to see them? Or is it that the number of consumers impacts or determines the price of going to the movies? Now, you could think of it both ways, but if you notice the way that the question is phrased, it's phrased in a way that would suggest that it is the price that's impacting the number of consumers going to see the movies. Notice what it says: if the price increases, then fewer consumers go to see the movies. So it's the price that moves first. And so for that reason, I am going to make price my independent variable. It's what's going to determine my dependent variable, which is now going to be the number of consumers. Okay. Now, what the relationship here is telling me is that as the price increases, so as we move this way on the x-axis, going to the right from left to right, then less and less number of consumers go to see the movies. So y goes down. So I have a negative relationship here that is best depicted by a line with a negative slope here. Notice in this line, as the x values increase, the y values decrease. So let me just pick 2 points. So for instance, let's say that I am right here on this line. Well, this line represents something, and what it represents is first the price that the movie is going for. Whoops, that is a little, go back, it's a little, okay. The price, so let's say that at this price we have, the price they're going to the movies is $30 a ticket. And you have a certain amount of consumers going to see that movie. So let's say that we have, let's just say, I don't know, 30 people, let's just make it easy. 30 people going to see the movie at the price of $30 a ticket. Well, what this line is telling us is that if the price of tickets increases, so let's say that it goes to, all of a sudden goes to $50, okay, then take a look at where we are on the y-axis. So we go up until we hit the line, and then, so here we are at the line, this dot, and now to figure out what number of consumers are going to the movies, we need to come across to the y-axis. And you know, I can make up a number here, but the important part is that it's lower, definitely lower than 30. So here, you know, maybe we have 10 consumers. So that's the nature of what it means to have a negative slope, or to have a downward sloping line from left to right, and that matches panel A. So let's now do B. Okay. So in part B, it tells us that more experienced workers typically have higher incomes than less experienced workers. So we have, as as I see it here, this is 1B, we have the level of experience of workers. Remember, our variables are typically going to be numbers, levels, prices. So level of experience of workers typically have higher incomes. I don't know to what degree this is an actual true fact if we look at our economy, but nevertheless, we'll do the problem. So level of experience of workers, and then we have income, whether it's higher or lower. Income of workers. And now I'm going to do the same thing. So I need to consider, in order to pick a panel that matches my relationship, I need to consider what is impacting what. So on my x-axis, I'm going to have my independent variable. And on my y-axis, I'm going to have the dependent one. So I need to ask myself, is it that the level of experience impacts the income? Or is it that the income impacts or determines the level of experience? I think not only the way that this problem is worded in a very specific way, but I think intuition would also match the idea that it's the level of experience that is determining income. Okay, so it's the level of experience. I'll just draw an arrow to say that it's the level of experience that impacts the income of workers. Now, wherever this arrow started is going to be your independent variable. So level of experience is going to be here on the x-axis. And that could be, in years, in decades, but we have experience on the horizontal axis. And then we have wherever your arrow sort of ends up, wherever this arrow is pointing to, is going to be your dependent variable. So this is my income. Okay, so now the problem tells me that as you get more experience, so on the x-axis, that means that as we move to the right in our experience, as our experience increases, then our income is also going to increase. So income is also going to go up. So what that tells me is that I have a positive relationship. When one variable goes up, the other also goes up. And a positive relationship looks like this. Why does it look like this? Well, let's consider comparing 2 points. So I'm just going to pick a random point on this line and say, okay, let me think about, the experience and income that might match this point. So maybe at this point, let's say I have 5 years of experience. So someone has 5 years of experience of, say, being a teller at a bank. And then over on the vertical axis, I have their income. So let's say that as a result of having 5 years of experience, the income that goes with that, let's say, is $40,000 a year. Okay. Well, what this line tells me is that let's consider what happens if I move over from 5 and say, let's double that. Let's say they have 10 years of experience. Well, in order to find out what their income is according to this line, I have to come up to the line, and that's at this second point here. And then I have to say, okay, well, what's my income? So I'll come across and consider the vertical axis. And at the vertical axis, I have that this is, and I'm making these numbers up. The important part here is that this is definitely higher than $40,000 a year. So I'll make up a number. Maybe this is $60,000 a year. Okay, and that's what it means to have a positive relationship. We've gone up in our experience, work experience, and we've also gone up in our annual income. Okay, let's do 1C. Okay, 1C. In 1C, we have that whatever the temperature outside, Americans consume the same number of hot dogs per day. So this question's worded a little bit in a bit of a tricky way, but we'll continue on the way we've been going. So we need to ask ourselves, what are the variables in this problem. So remember, think about something that can be quantified. So one of those things is definitely temperature. We can talk about the temperature in numbers. And then the other thing is going to be the number of hot dogs consumed. So now I'll continue on, and I'm going to make my axes. And I'm going to remember that on my horizontal axis, I have my independent variable, the one that's not determined. And then I have on the vertical axis, I have my dependent variable, the one that is determined or influenced by or dependent on the independent variable. So I'm going to think about the way that this question is worded. It says, no matter the temperature outside, Americans consume the same number of hot dogs per day. So the way it's worded, it's almost as if we would expect the temperature to impact the number of hot dogs per day. And I guess that makes sense. I mean, I would think if I had to say, think about a temperature and how many hot dogs people are eating, I would say, okay, well, when it's hotter in the summertime, people are barbecuing, and so they're going to eat more hot dogs. And so I would expect maybe as the temperature goes up that people are going to be eating more hot dogs. So, this sentence is saying that actually that's not what happens. No matter what temperature it is, people just love hot dogs and they're eating the same amount every day. So let me just, before I think of all that, together, let me just consider the intuition is that, or what we assume at first is that temperature will impact the number of hot dogs per day. It certainly is not the case in any world that we would expect the number of hot dogs consumed to actually change the temperature of the earth in a day in our town. So I'm going to list my temperature as my independent variable and the number of hot dogs as my dependent. The number of hot dogs depends on the temperature. At least that's what we would think. Okay, so now the problem says that no matter what the temperature is. So let me just think about what that means on my x-axis, because that's where my temperature is. On my x-axis, that means if the temperature is low, so let's say this is 20 degrees Fahrenheit, something of close to what it was the other day, so 20 degrees Fahrenheit. And let's say that this is 40. And let's say this is 60. And let's say this is 80. It's saying that no matter what, and let's go over to the y-axis and say, okay, let's list a number of hot dogs. Let's say this is people eating 1 hot dog per day, 2, 3, 4, and so on. So let's just imagine that we looked out into the world and we said, okay, when it's super cold outside, 20 degrees Fahrenheit, people are eating 2 hot dogs per day. And then when it gets a bit warmer to 40, they still are eating 2 hot dogs. Now here's where it gets tricky. Now we're approaching the summer or the springtime, so we're getting to 60 degrees Fahrenheit. But we look out and look at what happens. It's only 2 hot dogs per day. And then, most shocking, in the, right at the beginning of the summer when it's 80 degrees and nice out and people are just starting to barbecue again, we look out, nope, they're not eating more, only 2 dogs per day. So now when I, combine these lines, what I get here is just a horizontal line. And that's what it means to say that, there's no relationship between these two things. When it's cold, people are eating the same number of hot dogs as they are when it's warm. There's really no relationship between the temperature and the number of hot dogs consumed. And so this matches panel D. Okay, and now let's move on to part E. Okay, so 1E. In 1E, again, we have a problem where there's no relationship, but before we get worried about the complexity in that, let's just consider what our variables are. We have the number of diet books. Okay, and then we have purchased, so that's important. And then we have the number of pounds lost by the average dieter. Okay, let's just put number of pounds lost. And we're going to consider this relationship. So first, I really need to think about the intuition here and say, okay, well, I don't think I did 1D, but I'll go back and do 1D. Okay, so for 1E, let's just keep going with 1E. So I want to think about whether it's the number of diet books purchased that impacts or determines how many pounds a person loses, or if it's how many pounds that a person loses that determines how many diet books they buy. Well, the way that the problem is worded, and I think intuition would match, that it is what we expected was that the more diet books a person had, the more pounds they lost. Maybe we would think that, okay, well, if they're buying all these books and doing all this research, well, they're going to come up with methods that are going to help them lose weight more easily. So they're going to lose weight. It's less intuitive that would be that, you lost a lot of weight, and as a result of that, you go out and buy more books. So I am going to, as we've been doing, I am going to put the number of diet books purchased on the horizontal axis, because that's my independent variable. And then I'm going to put the number of pounds lost on the vertical axis. So now let me consider the relationship, what's going on here. They're telling me there's really no relationship. And so what that essentially tells me is that, let's consider a number, let's say, consider a different sort of different quantities of pounds that can be lost. So let's say a person can lose 10 pounds, 20 pounds, 30, 40. And let's say over here on the horizontal axis, we have the number of diet books. Whoop, that's a 1. Diet books that a person buys. Well, I expected that, hey, if a person goes out and buys 8 diet books, then they're going to lose more weight. Well, I look out and what do I find? I find that if the person who has 1 diet book lost 20 pounds, the person who bought 2 lost 20 pounds. And I'm really just making up this 20 pounds. It doesn't matter what it is. It could be 30 pounds. But the point is that it stays the same. No matter how many diet books you have, you're still going to lose the same amount of weight. And when I connect these, I just have a horizontal line here demonstrating no relationship. And this matches, again, panel D. Okay, let me go back and do 1D. Okay, so 1D. In 1D, again, what are my variables? Well, I have consumers buy more frozen yogurt when the price of ice cream goes up. So I have, maybe the pints of frozen yogurt. So I'll just say, because they didn't give me a unit, I'll say the amount of frozen yogurt that they buy. And then also the price of ice cream. Now this one's a little tricky because there's something that this problem is actually not telling you, and that is not fair. So let me explain to you what this problem wants you to assume about yogurt and ice cream. They want you to assume what is actually a lie, which is that yogurt and ice cream are substitutes, so that you don't care. So these two are pretty much equal. So you don't care whether you eat ice cream or frozen yogurt. Again, that's a lie. But you don't care. So you don't care if you eat yogurt or ice cream, and all you're really concerned about is the price. And so you're going to look at both yogurt and ice cream, and you're just going to go with the one that's cheaper. That's what it means for something to be a substitute, and we'll learn this in more depth later on in the class. But for something to be a substitute, it just means, you're going to easily substitute between one or the other. So maybe you you don't care whether you get turkey meat or roast beef for lunch. You know, when you go to the deli and you get sliced meat, you don't care if you get roast beef or turkey. You like them both. So you're going to substitute between either one of them. And really the only difference that, the only thing that's determining whether you buy one or the other is the price. So here, with substitutes, the idea is this. If the price of yogurt is really high, so if this is high, then you're going to buy more ice cream because you are going to just switch to ice cream. Yogurt is high. You don't care if you get yogurt or ice cream, so just buy more ice cream because the price of ice cream is low compared to yogurt. And then, so I'll put $sign here. So, and then if the price of yogurt is low, then you're going to, what is this? No. You're going to buy less ice cream because you're going to switch to yogurt. So if the price of yogurt is high relative to ice cream, it's cheaper than ice cream, you'll buy more ice cream. If the price of yogurt is more expensive, you're going to buy ice cream. If the price of yogurt is cheaper than ice cream, you're going to buy less ice cream because you're going to buy more yogurt. So you might have to hear that a couple times before it sort of really sinks in, the logic of it. So in this case, let's consider how we would graph this. So first, let's ask ourselves, where's the intuition? Is it that the amount of frozen yogurt bought depends on the price of ice cream, or that the price of ice cream depends on the amount of frozen yogurt that you buy? Well, both, again, the way the problem is written, and I think what would conform to intuition is that it's the price of ice cream that's determining the amount of frozen yogurt that you buy. So on the horizontal axis here, I'm going to put the price of ice cream. That's my dependent variable. Nothing's determining the price in this example, but the price is determining the amount of frozen yogurt that is bought. So that's my dependent variable. Okay, and this is telling me, the problem is saying that when the price of ice cream goes up, so when the price of ice cream goes up, increases, and that's a shift to the right on the horizontal axis, then the amount of frozen yogurt that's bought also increases. And that's a positive relationship. And like we saw in another example, the way that we illustrate that graphically is that the line is shifting upwards from left to right. Again, and I can show it to you, why, by picking just 2 points. So let me pick this first point on the line. If I consider what a price might be here, I'm just making this up. So let me say that the price of ice cream is, say, $3 a pint. Well, let's say that you buy a certain amount of frozen yogurt. Again, this is different. Frozen yogurt. Let's say you buy, 6 pints of frozen yogurt. Then let's say that the price of ice cream moves up. So it moves up, let's say all of a sudden, I don't know, for whatever reason, chocolate chips get more expensive for some reason. The price of ice cream goes up to $7 a pint. Well, where are we in terms of how much yogurt that we're going to buy? So we pick this point here that corresponds with the price of $7 that we've randomly chosen. And then we come across to the y-axis to say, okay, how many pints of frozen yogurt do we buy? I'm making all of this up, so I don't know exactly, but I definitely know that it's more than 6 because it's further up on the y-axis. And so maybe we buy, 8 pints of frozen yogurt in this example. Okay, and then last, let us do problem 1F. So 1F. 1F tells us, regardless of its price, Americans buy the same quantity of salt. So again, this seems to be a problem where we're going to have no relationship. So first, let me consider what the variables are. So I have the price of salt. And then I have the quantity of salt. Okay. And now I have to ask myself, because what I want to do is graph it. So I'll have my independent variable, the one that's determining another thing on the horizontal axis, and then my dependent on my vertical axis. And so now I had to ask myself, is it that the price of salt is determining the quantity of salt bought? Or is it that the quantity of salt bought is impacting the price of salt? Well, the way that this is worded, it's almost as if we would have expected that if the price of salt changes, that people are going to buy more or less. So maybe we would have expected that, like, with any other commodity, that if the price of salt goes up, that people are going to buy less. They'll just do without. And that if the price of salt decreases, then maybe people will buy more. They'll indulge. And what this sentence is saying is actually, no, that's not the case. But in any event, what we would have expected is that it's the price of salt that's going to impact the quantity of salt bought. So it's the price of salt here that's determining. And that will be my independent variable. And then the quantity of salt bought will be my dependent variable. It is being determined, or it depends on the price of salt. How much salt I buy depends on the price. Okay, and now it's telling me that no matter the price, Americans are buying the same quantity. So let's, to kind of really illustrate what's going on here, let's pick some prices. Maybe I have, I don't know, $1 a shaker, $2 a shaker, $3, $4. I have to do a better job of spacing this out. $6. Okay. And then on the y-axis, let's think of some salt. Let's say this is 1 shaker to, you know what I mean, those little cylinders. 3 shakers, 4 shakers. Okay. So let's pick a quantity of salt that we think Americans are buying. I'm going to say they're buying, say, 1 shaker a month. Well, if the price of the shaker is $1, that means that they buy 1. Now, I would have thought that if the price goes up, then they're going to buy less, but actually, they buy the same. This is just 1 shaker. At 3, they buy 1. At 4, they buy 1. At 5, they buy 1. At 6, they buy 1. When I connect this, what do I have? A horizontal line. This tells me there is no relationship. No matter the price, I'm buying the same quantity. And again, this corresponds with panel D. I hope this makes sense. If it doesn't, please feel free to visit me during office hours.